Let's explore the idea of a relative maximum and a relative minimum. First, we say that the function f evaluated at c is said to be a relative maximum if there exists an open interval containing c such that the y-coordinate for the c is greater than the y-coordinate for all of the other x values in that interval other than c itself. Similarly, f of c is said to be a relative minimum if there exists an open interval that contains c such that f of c is less than f of x for all x other than c itself. I know this is a mouthful, so let's translate this into the application. It's actually a lot simpler than it sounds. I like to just say, look for peaks and valleys, places where the graph kind of reaches a point where the behavior changes. And so it either could be a peak if that change happens at the top, or a valley if it changes somewhere at the bottom. So in the graph here to the right, we see that as we travel to the right, you can see where I'm tracing, we kind of hit this valley, and then we start going up. That valley is a relative minimum. Now, when we talk about relative minimum and relative maximum, we're actually talking about the y-coordinate. I know it's going to get a little confusing, so I'm going to show you in the next few examples exactly what that means. As we continue traveling across the graph, we then reach a peak. In that peak, we say that we have a relative maximum. So relative maximum, we can think of it as a peak. Relative minimum, think about it as a valley. Notice that as we continue in the graph, we find a second valley. A second valley means we have a second relative minimum. Now, there could be multiple relative minima or relative maxima, but there's always one absolute relative minimum or a relative maximum for any graph, unless we have infinities involved. Now let's look at the following example where we have the graph of the function in red. Notice that the graph does continue without bound as we move to the right. However, there's a very clear endpoint on the left. The first question is, on what intervals is the function increasing? Well, I see the function increasing in this part of the graph. I'm tracing it in blue. So we say that the graph is increasing between x equals -3 and x equals +2. So it's over this interval. Over what intervals is it decreasing? Well, let me erase here. I see decreasing behavior in this part of the graph. And then I see it again here. So I think there's going to be two different intervals. It's going to be decreasing between x equals -7 and x equals -3, and also decreasing between x equals +2 and x equals 5. Third question, for what values does f have a relative minimum? A relative minimum happens in a valley, So let me erase here. I see a valley right there and one right there. So there will be a relative minimum at x equals -3 and at x equals 5. And actually, I'm looking back and I think I missed something for part A. I also see that the function is increasing, and I missed this. It's increasing in this interval as well. So it's increasing between x equals 5 and +infinity. All right, let's go back to part D. What are the relative minima? Minima is plural for minimum. Well, this is a different question from part C, because part C is asking, what are the x values that have those relative minimum values associated with them? Relative minimum values are actually y values. So the actual minimum values are -2 and 0. So these two questions, these are the x values in part C, and in part D, what are the corresponding y values? So again, they come from these two ordered pairs where we saw those values. Next, it's asking, where does the graph have relative maximum values? Well, I actually see one peak only. One peak only. We wouldn't say that over here this is a peak because the graph doesn't continue. So we don't know if it would continue to move upward, if it would become constant, or if it would become decreasing. So we would not consider that to be a peak. The only true peak I see is right here at 2,5. So let me say not a peak, so not a relative maximum. This one is a peak. And so we say that at x equals 2, there is a relative maximum. Now the next question is, what is that relative maximum value? And now we look at the y value of 5. So the relative maxima, in this case is not plural, we just have one, would be 5.